All right, this is the final part 4 of the Math 136 practice final test. So we're looking at 22 through 28 in this setup. Starting with number 22, solve the following logarithmic equation. So notice this is multiple logs, but a non-log is on the other side. So when you have, not everything's a log, you're going to have to get logs on one side and the number on the other side, which they've already got that set up. Then our next step would be to combine this to a single log, which we use the property that says we would, if we're adding, we multiply the insides. So that's going to be multiplying x plus 67 times x plus 19. So we're going to have to FOIL that. And this equals 5. So this would be log base 4 of x squared. We're going to have 19 plus 67 in the middle because they're both going to have x on them. That's going to be 86x. And then 67 times 19. Sorry, my pen is frozen for a second. So 67 times 19 is 1,273. And then this equals 5. And then here's where you have to remember the next step. Since this is not logs on both sides, you have to do the conversion. You can't set this all equal to 5. So this is 4 to the 5th equals x squared plus 86x plus 1273. We need to know what 4 to the 5th is. So 4 raised to the 5th power is 1,024. So if you didn't catch that, that would really make this impossible to get the right answer, that is 4 to the 5th. So we're going to be subtracting. So I'm going to do this backwards just because I don't want to retype it. So it should be positive 249. So 0 equals x squared plus 86x plus 249. We need to look for factors of 249 that make 86, and they have to be same signs. So obviously we're going to make a list, 1 and 249. 2 should not go into it, but maybe 3 does. 3 and 83, and that's our pair. We got lucky. Didn't have to make a big list. So this factors into x plus 3 and x plus 83 equal to 0. So my two possibilities right now are -3 and -83, but you have to be careful. In a log, the arguments have to stay greater than 0. So -3 plus 67 is greater than 0. -3 plus 19 is greater than 0. So -3 is definitely an answer. But -83 plus either one of these is negative. So that guy is an extraneous solution and does not work. All right, let's look at number 23. This is find the domain and pick the graph, find the range, determine the asymptote. We're looking at graphing a log, and then we're going to be doing its inverse. So anytime you're looking for the domain of a log, you're going to focus on the argument. That needs to stay greater than 0. So that means that this needs to be greater than 4, and it's not an equal to. So this would be parentheses 4 to positive infinity. So what we need to look for is a graph that starts, it's kind of has its vertical asymptote at positive 4. So that's not this one. That's not this one. They're counting by 2s here, so this guy could be a possibility, or this one, because they're both at the 4, if you count by 2s, since they went to 10 and 5 moves. But this is how we figure out where it is. So it should be right 4, which is where we were at, and then down 2. So it's going to be C, because it went down 2, where the other one went up 2. The range of any logarithmic function is always -infinity to infinity. And the reason for that is it's the inverse of exponentials, and exponentials have a domain of all real numbers. So that means the range is all real numbers here. Vertical asymptote would have been at x equals 4, where we had that domain shift. Now, to find your not your asymptote, but to find your inverse, you need to rewrite your function as y equals log, and it was x minus 4, and then minus 2. And we're going to swap x and y. So x equals log of y minus 4 minus 2. We're going to try to isolate for y. So we need to add the 2 over. And then this is a base 10 here. Remember, if it's not written, it's base 10. So to get y out of that argument, you need to convert this to exponential form. So 10 to the x plus 2 equals y minus 4. So we're going to end up adding that 4 over to get y by itself. So that is my inverse. 10 to the x plus 2 plus 4. Domain and range of this should fall directly from the inverse property. So the domain of this guy is the range of the previous one, and the range of this one is the domain of the previous one, since they're inverses of each other. And then choose the correct graph. So this is a shift left 2 and up 4 if you think about shifting, and remember it's an exponential, so it should have that exponential growth shape. So left 2, that means this guy's out and this guy is out, so it's and then it's up 4. So see, this goes down, but this one goes up, and it goes up 4. It has that horizontal asymptote at positive 4. So it's going to be A. Okay, number 24 says solve the inequality f of x is less than or equal to 0, where you've been given this factored polynomial, and all you got to do is the graph. What this says is when are your y's less than 0 or equal to 0? Well, that means when are you hitting the x-axis and where are you negative? So if you think about the number line, breaking it up, anything from here to here on the x-axis, we have negative y's or a 0y. We also have that from here on. So this would be negative infinity to negative 1, and we would include a bracket, sorry, because it did say equal to. If it did not say equal to, we would make it a parentheses. Union with, and this was at 4, I believe. So 4 to infinity. Okay, for number 25, we're solving a log equation again, except this time we need to put this power back up first. You need to do that before trying to solve. So this is log base 2 of x minus 3 to the 4th plus log base 2 of 4 equals 6. We'll combine our logs using the multiplication argument property. To the 4th times 4. And I may not want to distribute this one. Sometimes I don't always do that because it really is going to be nasty to make that x minus 3 to the 4th and work it all out. So I'm going to go ahead and convert this to exponential form. So this would be 2 to the 6th equals, I'm going to put the 4 up front, 4 times x minus 3 to the 4th. We need to know what 2 to the 6th is. So that's 64. Equals 4 times x minus 3 to the 4th. I would divide both sides by 4 to get that x minus 3 to the 4th by itself. So that's 16 equals x minus 3 to the 4th. So we're going to need to take the 4th root of both sides to get rid of that root or that power. But when you do an even like this, you need to put plus or minus. So the 4th root of 16 is 2. So that's going to be plus or minus 2 equals x minus 3. And we're going to solve for both. So x minus 3 equals 2 or x minus 3 equals negative 2. Subtract, add 3 over this first guy is going to be 5. Add 3 over this one is going to be 1. So as long as both of those would make our argument greater than 0, they would be okay. But 1 minus 3 is a negative 2, so that's not going to work. So it only ends up being positive 5. Okay, moving right along. I wrote over the last one a little bit. This is one of the easiest questions on the entire test. If you know what an inverse is, you know all that needs to be done is the domain and ranges swap. So if this is the regular function, this is the inverse, then the range of the original is the domain of the inverse. The domain of the original is the range of the inverse. So pretty simple as long as you know the definition. Number 27 says solve the following exponential equation, express irrational solutions in exact form, and then round it to 3 places. So if we can get a same base on each side, which I believe we can, we don't even have to go smaller, we can use 9 because 81 is 9 squared. So this would be x minus 4 equals 2, which means x equals 6. So that is an exact solution, and I guess if they want to write it as a decimal, it would be 6.000 to 3 decimal places, since there is nothing but an exact number. And that leads us to our last question for the practice test. It says use the rational zero theorem to find all the real zeros of the polynomial function. use the zeros to factor it over the real numbers. That is important. We're not factoring over imaginary numbers, we're factoring over real numbers. So if you don't know how to factor a polynomial by looking at it, then what we use is called the rational root theorem or rational zero theorem, depending on the textbook. And that says you take all factors of the constant and you divide those by all factors of the leading coefficient, and you make a list of all of those possibilities. So my constant is got only one factor because the constant's 1. So it's either going to be a plus or minus 1. And then on the bottom, we have factors of 7, which would be 1s or 7s. So that list, if you split it out into now just individual pieces, would be a 1 over a 1 or a 1 over a 7. So that is the possibilities, all top numbers over all possible bottom numbers. So there's 4 possibilities. The next step would be to do synthetic division to see if any of these go into this with a remainder of 0. So if we put this 1 in the first box, I usually start with positive 1 and then I do negative 1. And we put our coefficients, making sure no powers of x are missing. If you were missing like the x to the first power, you would have to put a 0 in that spot. Otherwise, your division will not come out correct. It has to represent all possible places. Sorry, my pen likes to freeze up the more ink that gets on the screen. And then they have the negative 1. So when you're doing synthetic division, you pull down the first number and then you start multiplying and adding. So this would be 7, that's 6, 6, that's 13, 13, that's a remainder of 12. So that one does not work. Then we would try negative 1 usually, because most people will avoid the fractions even though they may be the one thing that works. So I'm just kind of going through what a typical student would do. So this is negative 7, negative 8, that would be 8 when we multiply, that's 15, negative 15, that's negative 16. So I did learn one thing by doing this. Neither one of these go evenly, but I'm going to try positive 1/7 first because I was closer to 0 when I used a positive number. So sometimes you can use that to guide your next choice. If it doesn't work, we'll end up doing negative 1/7. It doesn't hurt since there's only 4 possibilities. So we pull down the 7 and you do 1/7 of 7 is 1, that makes a 0. 1/7 times 0 is 0, bring down the 7. 1/7 of 7 is 1, there's our remainder of 0. So that means we definitely have one solution that is positive 1/7. Now this next part is 1 power less than what you started with. So we were x cubed, so this is now 7x squared plus 0x, which doesn't really count, plus 7. If you try to solve that, you'd factor out a 7, and that's x squared plus 1. This is imaginary. Anytime you have perfect squares with a plus between them and no minus sign anywhere in sight, that is an imaginary number set. In fact, it solves to negative I and positive I exactly because it's a plus 1. Because think about subtracting that over, it'd be x squared equals negative 1, take the square root of both sides, and you get plus or minus the square root of negative 1, which is negative I and positive I. So that doesn't help us for this part. So there's only one real solution to this problem. They did not ask for any imaginary solutions. It said real zeros. Then it said factor using real numbers. So essentially, we have a 7 out front because we pulled a 7 out of this guy. This factor right here, whatever that number is, you use the opposite sign when you're talking about it as a factor. It's as if you hadn't solved it yet. So if I solved this, it would move over and become plus 1/7. And then the last part is that x squared plus 1. So it doesn't really matter which order you write the two binomials in, but you need them both. So that is how this would factor over the reals. And that is the end of the practice test. So if you look at the guide that I posted a few days ago, it was probably a little bit middle of last week, I did put in a few extra problem sets that I thought would help you. Please look over that whole document because there are some different variations sometimes of how they word a question, and I wanted to make sure you saw all possibilities. So I will hopefully, if you send me an email anytime this week, be able to answer you right away. I'm just giving one final to my finite class. So please reach out if you have any questions or concerns, and good luck on your test. Oh, and don't forget, I will be checking the exams after they are completed for partial credit. So show all your work when you take your test. Thank you.